as part of the same video, we are supposed to, that depends on the research you are doing. If maybe you already have a valid tool, you only want to access the psychometric properties, you are good to go. But let's say you are adapting the tool into a different context. Maybe you are in the field of economics, in the field of health research. So with this, the first thing you are supposed to do is to check for the exploratory factor analysis to identify or to explore the factor structure before you confirm with the Amos, which is a confirmatory factor analysis. So I have my variables here. I have attitude towards people living with HIV/AIDS and also practice towards HIV/AIDS prevention. So the first skill, which is attitude, is made up of 11 items or indicators, whilst practice is also made up of 11. So all I need to do is to click on analyze. There's literature that supports that uh, even when you have non-normal data, a data that is or an item or with these variables not normally distributed, factor analysis is robust. And there's also research that indicates that although they vary, but most common is that you should have at least 100 sample size to be able to get good EFA, that is exploratory factor analysis. So I need to click on analyze. I'm using SPSS 27, that is statistics. You can use any other version. Click on analyze. Go to dimension reduction. You are going to see factor analysis. So since you want to identify the factor structure, you can decide to put only attitude inside to see. So we can decide, since we have two scale, can go with the first scale. We can click on this, hold shift, click on the last, select, check descriptives, KMO and Bartlett's test of sphericity. Okay, extraction, principal components. You can set your maximum likelihood with a minimum sample size of 200, or you can use principal axis factor. So I'll go with the principal component analysis. Eigenvalue greater than 1. But if you know the number of factors you need to extract, let's say you have 3 skills or you have 2 skills, and for the first time doing based on eigenvalue, you realize that you are getting more than 2 skills, you can decide to fix to the number based on theoretical assumption. So you can check for script plot. This gives you a graphical presentation of the eigenvalues and the number of factors to extract. So we click on continue. Rotation, we use varimax. Based on your own research, you can decide to use cutting max, equal max, pro max, direct or limit, based on what you want. You click continue. So the next thing we need to do is to click on OK. Then you can resize. So you look at the Kaiser-Meyer-Olkin measure of sampling adequacy, which is 0.957, which from literature, although it varies, above 0.6 is adequate or exactly 6. So since we have above 0.6, which is almost like 1, ranging from 0 to 1, it means that the sample size is adequate for this. And also with the Bartlett's test of sphericity should be statistically significant, which is so it means that we are good to go. The next thing is to look at the communalities. We have the initial extraction and the extraction. So initial extraction was 1, while the extraction is, so this is the final communalities. And for the first item is 0.66, which is above 0.5. That one, literature also varies. Some will say communalities above 3 is okay to go for confirmatory factor analysis. Some will say 0.4, some will say 0.5, some will say it should be at least 0.7. That varies based on your research. But I've seen during analysis you have a communality less than 0.4, but once you go for the confirmatory factor analysis, you will have them with loadings above 0.6. So we go with here. The next thing is to know the total variance explained or extracted. That's based on the eigenvalue. So you give eigenvalue above 0.1. So if you have so many components, let's say you can have single component, and if the eigenvalue is above 0.1, it means that it's going to be 2-factor structure. But if you only have one component with eigenvalue above 1, then it means that you have 1-factor structure. So you see, it means that only 1 factor extracted, because this is 0.5 less than which is less than 1. So you look at the total variance explained in percentage is 76.16. And literature also says that if you don't have if total variance explained to be at least 0.5, it means that you have a poor tool. So it means that you should have at least 50% of total variance explained to make your study or your tool valid and to continue with confirmatory factor analysis. But that one can also vary. You may have that less than 0.5, which is 50%, and you can still go with analysis. It's based on the type of research you are doing. So with the eigenvalue, there's a graphical presentation of that, which is a script plot. So with the script plot, you see that we have a bend in here like an elbow. So this is the eigenvalue, which is 1. So it means that you need to draw a line across. So once you draw a line, you see that you only have one factor structure extracted. So it means that only one component or factor or latent variable. So this is the extraction that we have using the principal component analysis. So if we were to have eigenvalues, maybe 2 components above 1, it means that we might have 2 components. If it is above, well, maybe 1 for 3 components, it means that we have 3. So you see that this is the final. So you see that our loadings, in fact, we have good loadings. The loadings with the minimum is ATT10, item 10 with 0.783. So that is all about the EFA. So what we need to do is to go back and do for the next skill. So we apply the same theory. We go to this dimension reduction of the analysis. We remove this, put in the next skill, and go through the same. So since we have our settings, we don't need to change it again. Click OK. So look at this. It's also 0.95, which is above. So you see, this is the second factor analysis. That's where if you click, it sends you to it, which was 0.957. So this is 0.95, which is also adequate. We still have the same communalities. Final communalities, the minimum is 0.5. Wow, that is so good. Component extracted is 1, so you see it's only 1. The second component is less than 1, so it means I only have 1 component or factor extracted. It means that there's unidimensionality of our scale. It means that it only measures 1 construct. So we'll go with the eigenvalue. Look at the script plot. It's also the same. Extraction also with the lowest, which is item 2, or PRA2 with 0.7, which are all above 0.7 criteria. So now we can decide to confirm the unidimensionality of our tool again by trying to conduct another CFA, EFA to see whether there will be closed loadings or whether the items are actually measuring what they are supposed to. So since we consider this to be a new tool based on the adaptation we did or based on the new the new skill we have developed, we'll go back with the factor analysis again and we'll put in all these two. So if you are doing one skill, we are good to go. But if you are doing two, you can decide to check to see. So we'll click on this, we'll drop it again and go back again. So we still have the same measures which are adequate loadings. When you look at the communalities, you see that the minimum was 610, which is good. Let's go. So you see we have 2 components. So this is normal because we have 2 scales. So here you see the third one, the eigenvalue, is less than 1. So it means I only have 2 components extracted. Let's look at the script plot. So you see the bending, the elbow. Although it starts here, but it is where we can feel it. So it means that we have 2 components extracted. So you can see. So look at the ATT. You see that they are in 1, and that is a negative. So it means that there is no cross loading. You see. So let's look at this one too. Okay, but you can see that although we have 2 components, but these, okay, this was without extraction, and this is now the rotation. Yes, sorry, this was the first without rotation. That's just the principal component. So now this is the second one rotated. So you see that from ATT, it ends here. That's all above 0.7. Then the next one starts from here. So you compare the loading. So if you see PRA1 to be 0.3 for one component and higher for the other, it means that it's loading onto the other component or factor. So you see they are also on a difference. So it means that when we try to suppress this loading, so we can decide to go back again, analyze, dimension reduction. So we can say scores. Sorry, let's use this option. Suppress those less than 0.4, 40 or 0.40. Try again and come back to the last, and you can now see them clearly. So you see that we have all of these items loading onto their various factors or loadings related variables. So that's basically how we do for the exploratory factor analysis using the principal component analysis extraction. But we can decide to also use principal axis factoring, which is about the same thing. We try when it comes to extraction, we talk about principal axis factoring. Our sample size is 350. We can decide to use maximum likelihood. So you can also try to see which one best fit for your data. So since we choose principal axis factor, let's try to see whether we are getting similar results, although the estimates or the loadings might differ. So you see, with this, the lowest with the principal component was 0.7, but with this is 0.6. So we still have the same. It means that we have good. So we can try again with the same using maximum likelihood. So we'll go to factor analysis again, extraction. We'll come to maximum likelihood because we have a sample size above 200. Then we try again. We still have the same communalities here, although they are this one was the lowest, which is 0.491, but we can still go since it's above 0.4. So let's look at the number of factors extracted or components. Also two, eigenvalue the same, script plot the same, initial extraction this, rotated extraction. See, so this means that we have a good scale and we can move on with our confirmatory factor analysis for these two scales. But I forgot of something. You see, we were just moving from analyze. To make it easy for you, you can just click on this with the drop down. That's recall recently used dialog. Click on this and you see factor analysis. Then you can click on it and continue instead of starting from analyze, dimension reduction, then also factor analysis.